Today we are going to look at the ideal gas equation. The ideal gas equation. The ideal gas equation is giving us PV over T equal to R. That is what we call ideal gas equation. So if we cross multiply, we are going to have PV equals to RT, where R is the proportionality constants or gas constants. Proportionality or gas constant. In some cases, we call it molar gas constants. Now, this molar gas constant is derived from PV R PV over T. R P is PV over T. Now, where we have the P to be 1 atmosphere and the volume, we use the molar gas volume, which is 22.4 dm³, all divided by the standard temperature, which is 273 Kelvin times. We are looking at 1 mole of a gas, 1 mole. And when we divide, we will get 0.082 dm³ atmosphere per mole per Kelvin. This is what we call molar gas constant, or the proportionality constant for gas. Now, if we are talking about assuming, supposing we have N to be number of moles in a given gas sample, N to be number of moles in a given gas sample, the equation becomes PV equals to nRT. PV equals to nRT, where N is the number of moles of the gas we are dealing with, R is the molar gas constant, or the one we call proportionality constant, then P, pressure, V, volume, and T, temperature. Now let's take some problems. All right, let's solve this problem. Calculate the temperature of 0.5 mole of an ideal gas, which occupies a volume of 20 cm³ at 1 atmosphere, given that the molar gas constant is 0.082 dm³ atmosphere per mole per Kelvin. So how do we go about this? We state the ideal gas equation. PV equals to nRT. PV equals to nRT, and we're asked to determine the temperature. So our T is PV over what? nR. And what is our P? What is our P? 1. That's 1 atmosphere. And our V is 20. And our N, that's the number of moles, is 0.5, while our R is 0.082. And this will give us 487 487.88 Kelvin. Then if you want to convert to degree centigrade, we will now say 487.8 minus 273. All in degrees was centigrade. And that will give us 214.8 degrees centigrade if we are to convert to centigrade. Now let's look at a second problem. It says, how many moles of a gas are contained in an ideal gas which occupies a volume of 15 dm cube at 0 degrees centigrade and 1 atmosphere? So first of all, we convert our temperature. Our T is 0 degrees centigrade. So we are converting it to Kelvin. So our T is 0 plus 273, all in Kelvin. And that will give us 273 Kelvin. So we state our equation, PV equal to nRT. We're looking for N. N is PV over RT. And what is our P? 1 atmosphere. And what's our volume? 15 dm cube. And what's our R? Is the constant, 0.082. And our temperature is 273. And that will give us 0.67 moles. 0.67 moles.